So if we're doing IVT, intermediate value theorem, we have our f of x is equal to 2x minus x squared on our interval -1 to 2, and we have our w is equal to 1, or w is equal to -1. Well, w is just equal to f of c, so whenever you see that, just think that. So the first thing that we're going to do is we're going to find our f of a. F of a is equal to f of -1, which is equal to -2 plus 1, which is -1. Our f of b is equal to f of 2, which is equal to 2 times 2, which is 4, minus 4 is 0. Good. Now our b itself is 2, so b is equal to 2, and our a is equal to -1. So if we have a is less than or equal to our c value, which is less than or equal to our b value, then we have -1 is less than or equal to c, which is less than or equal to 2. And if we look at our function values, then we have our f of a is less than or equal to our f of c, which is less than or equal to our f of b, which is all true because, let's erase this part, our f of a is equal to -1, which is less than or equal to -1, which is less than or equal to 0. So if a is equal to -1, we'll just move it over, b is equal to 2. So now we have to find our c. So let's find our c. So find c. So if we know f of c is equal to -1, then 2 times c minus c squared is equal to -1. So if I multiply everything by -1, I have a c squared minus 2c is equal to 1. So then c squared minus 2c is equal to -1 equals 0. That's unfortunate, because that means we need to do the quadratic formula. I can't think of any quick factors there. Yep, can't think of any quick factors. So if we do quadratic formula, x is equal to -b, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times a times our -1. A is just equal to 1, all over 2 times a, which is 2. So this is equal to 2 plus or minus the square root of 8 over 2. So our c is equal to 1 plus or minus the square root of 2. And all I did to get that was simplify my 2 plus or minus 2 root 2 over 2. So here we go. So now that we have all our values, the ones we have to make sure that we remember to keep track of is a is equal to 1, b is equal to 2, f of a is equal to -1, f of b is equal to 0, c is equal to this, f of c is equal to -1. These are all the ones that they want us to graph. So through intermediate value theorem, we found a c on our interval that exists, and these are all just basic work that we've already done. So now we just want to draw a graphical representation. Alright, so get all this down, and then we're going to clear everything. So f of a was equal to -1, f of b was equal to 0, b was equal to 2, a, and that's the same color, that's what I want. A was equal to -1, f of c was equal to -1, and c was equal to 2 plus or minus root, no, it was 1 plus or minus root 2. Alright, so now let's look at a graph. So A was at -1, B was at 2, f of A was at -1, f of B was at 0. Okay, so A is here, f of A is at -1, B is here, f of B is equal to 0, and my C is 1 minus root 2. Well, 1 minus root 2 is outside of our interval because would it be? Alright, some quick calculation on the calculator. Square root of 2 is, so it's 1 minus 1.4, which equals -0.4, not outside our interval. I lied. Alright, so we're at -0.4, so there's a c value here, and then 1 plus 1.4, that's what outside of. So 1 plus the square root of 2 is equal to 2.4, which is outside our interval. So if our f of c is equal to there. So using these 3 dots, we're going to kind of, I'm sorry for all the colors, but we're going to kind of create a function that goes through all of them. So graphically, we want to label all of them. So if you just follow color-wise, this is A, this is B, this is C, and then going for our function values, f of A is here, f of C is here, and f of B is there. So they just want you to know what's going on, how to use those letters and things to figure out what your intervals are.